What's up, Audiophiles? I'm here today with Andreas Koch of Playback Designs. This is an interview I've been waiting to do for a while. It's a privilege to talk to a real digital designer, and which is a kind of a rare thing in the high-end audio. How you doing, Andreas?
Thank you. Very good. And you, Gary? Thank you for the opportunity.
It's great seeing all that test equipment in the background.
Yeah, some of it, the bottom, but the top are actually products, the dream products.
Oh, that's good. So let's go ahead and get to our little presentation. Okay, so of course your model, the finest audio playback in the world, but this is one of the products where you can really say that. It's got some interesting features that other products just don't have. So we're going to take a quick look at your background. Now, you started with Studer in Switzerland.
Yes.
That was a little while ago, right?
That was a while ago, right after college, and the company Studer was on my way to college, and I always kind of looked over it and say, it would be cool to go work for there. And Studer himself, he advertised open jobs at the college. And when I finished, or was close to finishing up there, I grabbed the opportunity and went there and met with him, had dinner, and just fell in love with the company.
Wow, that's amazing. So did you start originally, went directly into digital design?
Yes, yeah, that was my background, digital signal processing. And those were the early ages of digital or digital signal processing, digital audio in general. And I felt like I have to be at the forefront of technology and just push the front a little bit.
Was this a lot of hardware design as well as software design at this point?
It was mostly hardware design because the hardware was at its limit. Actually, it was not the available hardware was not fast enough to do digital audio processing. None of the processors that were available could handle anything. Not even 44.1 kilohertz or 16 bits. That was just unheard of. So we had to build a lot of hardware, parallel paths, and a lot of special stuff to get it done. But it was limited.
Right, that's amazing.
Yeah.
I know you had a long career in digital design. Now, the thing that most audiophiles know about you is that you were at Sony. Can you talk a little bit about that?
Yeah, at Sony, I was hired specifically for the SACD project. And when you launch a new audio format, not just a disc format, but also a recording format and a DSD, then you have to build a lot of stuff, and you have to convince the recording community, also the consumers, to invest in that technology. It's a big entertainment, for companies like Sony and Philips. So they joined forces, and the task was to develop DSD enough so that we could present it to the recording industry and also the consumers. And with my background in professional audio, that's how I started, just purely professional audio. I knew how to build editors and mixers and recorders, and basically had the contacts in the industry. And for that reason, Sony hired me to design the Sonoma workstation, which is the world's first DSD workstation, recorder, editor, and mixer.
What is your thoughts on DSD? Why do you feel it's superior?
Well, that's actually very easy. And, back in the 80s, converters were just straight converters like ladder and so forth. And they were limited. And in, I believe it was in late 80s, 87 or 88, the new idea was born that we could use delta sigma modulation first as the first stage, and then use digital signal processing to convert to PCM. So every A to D and D to A chip from there on was built with delta sigma modulation. And the quality improved quite a bit, significantly. And so the thought was, what happens if we just drop the digital signal processing after the sigma delta modulator? Should be better because there's less processing involved. And that was the idea behind DSD, because DSD was already part of every PCM converter. We just went straight to the DSD signal without doing the detour of PCM.
Right.
And for most people, for most audiophiles, that is true, and I know a lot of people agreed with that. And so that was the idea. And I think initially the search was more for an archival recording format, not so much a release format. Because when you record, you want to have the best possible quality so that from there on in the future you can downsample or mix or release anything in PCM. And so DSD was meant to be an archival format. But then I think it was in the early 90s, the format war started between DVD audio and Sony and Philips being invested in the CD. They were kind of left out and said, we need to have another format that has superior audio quality. And so the idea of SSCD was born then.
Oh, that's really interesting. That does. I didn't realize it was meant to be originally an archival format, but that does make sense.
Yeah, and it was clear the recording industry actually got together and formulated, I think it was 10 requirements for any new format. And one of them was, of course, increased sonic performance compared to CD. So it had to be something better, higher sample rate, or bigger word length, or whatever makes it better than CD. Mm-hmm. And the obvious choice was PCM at higher sample rate, longer bit lengths, but there's no proprietary technology involved in it. We're talking right. Sony and Philips, so they want to have something that is somewhat proprietary. And PCM with 96 kilohertz and 24-bit or even higher, has the disadvantage of word lengths. I mean, there's the space constraints on the disc. SSCD is basically just a DVD platter or a physical platter, and you have only 4.7 gigabyte of storage there. And if you're running at 96 kilohertz or anything above that, you fill that pretty fast. And that's where DSD had an advantage. It was more bit efficient at higher quality.
Oh, that's interesting. Well, that explains a lot right there. Now, I know that after a long career in digital, you decided to start Playback Designs. What brought this?
Sorry, say that again.
Why did you decide to start your own company? I know you were a consulting engineer for a long time.
Well, yeah, after the SSCD campaign, Sony and Philips, they both decided that DSD is out of the eggshell and can live on its own, and they basically pulled the plug on any research and development. And that strained me a little bit. I didn't want to continue with Sony much because there was no interesting projects. And so I thought I would leave and take the idea of DSD and SSCD on and create DSD-based products that take advantage of the technology. Sony allowed me to use any technology based on DSD. And, I thought there's really some merit in DSD, and if we can take that to the consumer level, and, there's an opportunity there. And DSD was already at the consumer level through the release of SSCD.
Well, that's interesting. So the impetus.
Yeah, with that, of course, it didn't make sense to buy an SSCD disk and then play it on a player that converts everything to PCM the way it was standard at the time. Because then you lose the advantage or the basic idea of DSD. So I thought, there's an opportunity for me to build products that don't do this detour to PCM, but convert DSD directly to analog, the way I've done it, the first 10 years.
Right.
So that was the idea, and I was right, and it was a fairly easy start with Playback Designs in 2007, and we were profitable right from the beginning, and we're selling these products worldwide within a few months.
Wow, that's fantastic. So do all of your products process internally DSD, even PCM, like when you're playing a regular CD?
Yeah, I stayed true to my initial doctrine to always do DSD processing natively and convert directly to analog, and that's why we use FPGAs to process DSD, because none of the processors out there available on the shelf are 1-bit based, and are basically PCM based and a multi-bit.
Right. We're going to talk about that on the next slide. So we're going to talk a little bit about FPGAs. So for the people that don't know what an FPGA is, what is it?
Yeah, it's a pool of gates, the basic building element of digital logic. It's a gate. It's like an AND gate or an OR gate, and a very, very basic thing. And it's basically a transistor stage with a few different inputs. And if you gang those up together with a flip-flop and a little storage, a 1-bit storage unit, you get the basic building block of an FPGA. And there's thousands of those in a chip. So you can basically build your own processor. You can have a 1-bit processor, you can have a 72-bit processor, 108, whatever you like. It's very flexible in that sense. A little bit more difficult to design for, but it's the perfect environment for DSD processing.
And this is the one point I wanted to emphasize with the Playback Designs, and the FPGA DACs are different than the regular. Most of the DACs on the market are using off-the-shelf chips, which are not programmed, and they interface with them in different ways and different analog stages. But the FPGA uses your proprietary digital algorithms, which are the real essence of the product.
Right. Well, the disadvantage of using standard off-the-shelf chips is that you're constrained to whatever that particular chip is doing inside of it. And usually those chips are designed for measurement performance. They measure really nicely. They have all the noise floor down, no noise shaping, those DSD high frequency effects. They take them out. And in order to take those out, you have to use heavy duty filtering to a point where you can argue this is not DSD anymore. It's actually PCM, what's coming out of it. Whether you have some high frequency noise that is above a typical PCM level, well, you can argue there. Is it audible or is it not audible? It's certainly audible when you introduce a brick wall filter and have all kinds of other side effects of heavy duty filtering. So with an FPGA, you have the advantage that you can do whatever you want, whatever you think is best for the performance. And if you want to let through some of the DSD characteristics and for the benefit of less filtering, less heavy-duty filtering, you can do it. And if it sounds better, perfect. If it measures better, who cares?
That's interesting. The first time I saw the Playback Designs, I believe it was at Rocky Mountain Audio Show, now sadly defunct. And I was working in the ATC room with Brad Lundy of Lone Mountain Audio.
Oh, yeah.
And we're sitting there, and he said, "You know what?" He went over to your room and he said, "You know what? You got to hear this DAC. This is a really good DAC." And I have never heard him say anything like that before. So I said, you know what? I got to go over there and check this thing out. And you were doing a demo where you had a tape deck as a source. And one channel you ran straight through to the system. And the other channel you went through your A to D, D to A chain. And that was amazing. A lot of people pick the A to D, D to A chain as the one that was straight through.
Right. That was a really interesting setup. And we had 3 golden ears, and I gave him my remote control, and I didn't tell him which button or which input is digital and the other one analog. And I just wanted to hear from them whether they can hear the difference. And after 5 or 10 minutes of discussing it, what they heard, they said, we do hear a difference, very slight, but it basically comes down. It's not so clear what is better, so it basically comes down to a matter of taste. Which one do you like better? And they argued that the one that they like better must be analog. Well, it happened to be the digital one.
Yeah, I did the same experiment myself with a customer.
Yeah, and for me, that was kind of proof that we are close to analog, so close to analog that it's not so easy to tell the difference anymore.
I agree 100%. Now, like I said, the core of all the DAC procs are the FPGA and your proprietary algorithms, which are amazing in my point of view. Let's talk a little bit about the rest of the design. Now, let's talk about the output stage.
Sure. The Dream DAC was designed with the intent to build the best possible DAC that with our technology that we have built up and over the years, and no digital sources like streamers or disks or servers inside. This all has to be outside because ultimately they impact the performance. And so in order to increase the performance, we built the analog output stage in 4 individual separate parallel paths per channel. So if you want, it's actually an 8-channel D2A converter, not the digital side, only the analog side. And we take 4 of these parallel paths together and create one single output. By doing that, you increase the signal to noise ratio and other performances. I'm not going to go into a lot of details there, but it helps. It's expensive, of course, but it helps the performance. And since we tried to build a flagship, this had to be done this way.
Right now, I know people are going to ask. I know you had to change the output stage because some of the devices went, I believe they went obsolete. So you changed the output stage on the new DAC.
Yeah, well, several things came together. One was that some components went out of production, and there were some replacements. But at the same time, we also got requests from several markets to add an analog input. Leave the product alone by itself, the rest of it, but just add analog inputs because the internal volume control is so good that a lot of people wanted to just use that and get rid of their separate preamp. And so a change was necessary for the analog output stage so we could get the analog input into it directly without going through the digital path.
Right.
And so we combined. We combined everything together and redesigned this board to take advantage of new products and new chips, new technologies. Redesigned that slightly, not huge, and also added the capability to take in an analog input.
Right now, the difference between your product and a lot of other products, a lot of the other products will take an analog input, but they'll digitize it and run it through the digital circuitry. Yours is actually a true analog path. which is important to know.
Yeah, it's true analog path, very short. I mean, there's no reason. You want to go analog out to your amp or preamp, so why convert to digital and then right back to analog again? You know, that's an additional signal processing, and every time you have an additional step in there, you sacrifice the quality.
No, I agree. So, and also your product also has complete isolation of the analog and digital stages. How does that work?
Yeah, I mean, that was a design criteria. And if you want to build a really good DAC, you need to separate an analog from digital and also left and right. And we took that separation all the way to the power supply. And so each analog output stage has its own separate power supply with transformer. And also the digital side has its own separate power supply. So there's three power supplies, individual power supplies in that thing. It's pretty full. That's why it's so heavy.
Yeah.
But that really makes a difference. And you know, with the philosophy of taking all the digital sources outside of the box, we added another level of separation. Because every time you have a processor, a disk drive, an SSD drive, or a server, or a streamer inside the same box, taking the same power supply as the DAC, then you know, you're compromising it, because all kinds of clocks are flying around, all kinds of electrical noise is flying around in the same box, and you know, it's very hard to take this out, actually impossible. The only way to do that is keep it outside of the box and link it with a non-electrical connection.
Yeah, your P-Link process, which is...
That's the P-Link, and that's a very high quality fiber optic link. So it's not Toslink, it's fiber optic with a rated speed of 100 megahertz.
Wow, that's fantastic. Well, we're going to cut this video at this point, but I'd like you to come back and talk about your new amplifier. You're developing a new amplifier, right?
Right. That would be wonderful.
Hopefully you can come back when I talk about that. Again, this is Andreas Koch from Playback Designs. Thank you so much for coming by, and we'll talk to you soon.
Thank you so much for the opportunity. Bye, Gary.
Bye.